All right. Oh, this is not focused. I'll try to get it focused. But we are going to be talking about 2.4, still standard B, and we'll be solving equations with the variable. Why can't I get this to focus? This is not good. What in the world? Oh, come on. Okay, there we go. So 2.4, solving equations with a variable on each side. Okay, so equations that we've been solving so far have looked kind of like this. So this is review, or this should hopefully be review. Otherwise, you might learn something here. So if we had 2 plus 5k equals negative 6. All right. Oh man, it's gonna be like this. Okay. Oh boy, this could be a rough one. All right, so we want to solve this equation. Well, to solve it means we need to get k alone. Okay, so we're going to be using inverse operations, doing our order of operations in reverse order. So in reverse order, we do addition and subtraction. Okay, so our 2 is being added. So to get rid of it, we'll subtract 2 on both sides. Okay, so these will cancel, and we have 5k on this side of the equal sign, and the negative 6 minus 2 is negative 8. Okay, and then we need to get rid of this 5. Well, 5 is being multiplied by the k, so we need to divide by 5, because division is the inverse of multiplication. So those 5's will cancel. We're left with k equals negative 8 over 5. All right, so what we've been dealing with is we'll have one variable showing up. It's only on one side. Now, let's say we had something pretty similar. What if we had 2 plus 5k equals 3k minus 6? Well, what do we do here? We have a k over here and a k over here. Well, we need to get the k on one side, right? We need to get k by itself, but with k on both sides, that's weird. We need to get k equal to something. So like we did before, we can subtract 2 and subtract 2. Now, remember, when we subtract, we are combining like terms. So I could write this out as 2 minus 2 plus 5k equals 3k minus 6 minus 2, right? That's what we're doing in this step here. All right, 2 minus 2 is 0. So I have 0 here plus 5k. Well, that's just 5k. Okay, over here, we have 3k minus 6 minus 2. Combine like terms. All right, there are no like terms on the side with the 3k. We have negative 6 minus 2. Negative 6 minus 2 is negative 8. All right, so what do we do about these two k's? Well, that same thing that we do with these whole numbers or any other constant number, we can also do that with these terms that have variables. Okay, so over here, we're adding 3k. We have a positive 3k minus 8. Let's subtract that 3k. So on this side, we will have minus 8, right? These 3k's will cancel. 3k minus 3k is 0. But if we do it to one side, we also have to do it to this side. So we have to subtract 3k. Combine like terms. Make sure that these are like terms, which they are. They have the same variable and the same exponent. So we do 5k minus 3k, which is 2k. All right, now we have our k's on one side. Right, we don't have a variable on the other side. And this is something we can do. Divide by 2 on both sides because we're multiplying by 2 over here. So that cancels. Negative 8 divided by 2 is negative 4. K equals negative 4. All right, so the only difference going from what we did before and what we're doing now is that instead of having our variable already on one side, we have variables on two sides. So what we do is we just pick a side we want to put the variable on. We could have done minus 5k, but then I would have ended up with a negative over here, which is a little annoying to work with. So I subtracted 3k so that the k's were all on this side of the equal sign. Let's just do another example. All right, I'm gonna section these off because I go crazy with them. All right, so an example. How about 5a plus 2 equals 6 minus 7a. All right, we have a's on both sides. Looking at this, I'd rather add than subtract. So I'm going to add a 7a to cancel my a's over here and put my a's over here. But if I add 7a on this side of the equal sign, to get these to cancel, I'm going to add 7a over here. Now, I put it right under the 5a because I'm recognizing that these are like terms. They have the same variable and the same exponent. I can't add the 7a to the 2 and simplify that. They're not like terms. The 2 has no a on it. All right, 7a or 5a plus 7a is 12a. We still have that plus 2 equals, we got rid of this minus 7a, so we're left with 6. All right, now this is something we've done before. Okay, we want to get the a by itself. Work back, we do our order of operations backwards. So I'm going to start with addition and subtraction and get rid of that operation on this side. So to get rid of the adding 2, I'll subtract 2. I do it to this side as well. Those will cancel, that's why I'm doing it. So I have 12a equals 6 minus 2 is 4. And now I have to divide by 12 on both sides. Okay, 12 divided by 12, do that to cancel. Right, and we're left with a, 4 divided by 12. Okay, that's, let's see, 4 over 12 is a fraction, but we can reduce that, right? 4 and 12 can both be divided by 4. 4 divided by 4 is 1, 12 divided by 4 is 3. Okay, so 4 over 12 can be reduced to 1/3. A equals 1/3. Let's check that one. All right. So let's check it. So I'm going to put 1/3 in for a. Let's get some good fraction practice in. So 5a, so 5 times 1/3 plus 2 equals 6 minus 7 times 1/3. Okay, this one's going to be really fun to check. So we have 5 times 1/3. Well, that's 5 over 3, right? Because I can write this as 5 over 1. So 5 times 1 is 5. 1 times 3 is 3. So 5 over 3 plus 2 equals 6 minus 7 times 1/3 will be 7 over 3. All right, so to add these, I'm going to get a common denominator. So I'm going to write this as 5 over 3 plus, let's see, 2 over 1. I'm going to do it the same time I am. Actually, we'll do this one first. We'll do this side first. 5 over 3 plus 2 over 1. Again, a common denominator. I'll do the butterfly method. So I'm going to multiply here to get my new denominator. So 3 times 1 is 3. And then multiply across here. 5 times 1 is 5. Plus 3 times 2 is 6. Okay. 5 plus 1, or not 5 plus 1, 5 plus 6 is 11. So I have 11 over 3. Okay. So I did this side. Now let's see if this will also get us 11 over 3. So I'll write it as 6 over 1 minus 7 over 3. We'll do the butterfly method again to get our new fraction here. Multiply the bottoms. 1 times 3 is 3. 6 times 3 is 18. We're subtracting, so minus 1 times 7 is 7. Okay, 18 minus 7 is 11. 11 over 3. Awesome. It worked. Looks good. All right. So that's what we're doing with variables on both sides. We just need to treat those variables like we have been treating just normal numbers and putting them to one side so we can get our variable alone. So there's another kind of example I want to look at. Okay, let's do another example. And let's do 6 times 5m minus 3 equals 1/3 times 24m plus 12. Oh, come on, please focus. There we go. I guess I just have to keep my hands in here for it to focus. Each side here should look pretty familiar from 1.4, the distributive property. So I'm trying to simplify this. I don't know what to do first. I think I'm just going to start by distributing. All right, so I'm going to do this side first. Oops, that arch didn't go far enough. My table's got a weird divot in it. Okay, I want that one to go over here. Okay, so my two arches, I have 6 times 5m. Well, 6 times 5 is 30. Okay, so I have 30m. 6 times minus 3. Well, 6 times 3 is 18, so 6 times minus 3 is minus 18. Okay, so that's that side. Distribute again. 24m times 1/3. Okay, multiplying by a third is the same as dividing by 3. 24 divided by 3 is 8. So 8, m, I almost forgot my m. So 8m. Distribute that 1/3 to the 12 as well. Okay, we forget that a lot. Remember, when you distribute to both sides of our operation. 1/3 times 12. That's the same as doing 12 divided by 3, which is 4. So plus 4. Okay, let's get our m's on the same side. So I'm going to, well, if I get it on my m's on this side, I would subtract 8m and subtract 8m. So I can do 30 minus m. If I were to put my m's on this side, I would subtract 30m, subtract 30m. Well, I'm going to get a negative doing that. 8m minus 30m will give me a negative. So I'm going to keep things positive. So I'll subtract 8m from both sides. All right, so I subtracted the 8m, so these would cancel, and I'm left with the positive 4. Over here, 30m minus 8, that'd be 22m. We still have minus 18. These are not like terms, so it's as simple as we can get that. Now we're just trying to get m by itself. Do our order of operations backwards. So addition and subtraction first. So we want to get rid of this minus 18. Well, to get rid of subtraction, you add that same amount. So add 18. Got to do it to the other side too, so it stays balanced. Get that so it cancels. So I'm left with 22m over here. 18 plus 4, or 4 plus 18 is 22. All right, hopefully you can see the answer at this point, but we will keep going. We need to get m by itself. So we have 22 times m, so let's divide by 22 to cancel those. So we're left with m over here, but we did dividing by 22 over here. Got to do it on the other side as well. Keep that balance. 22 over 22, what's 1? M is 1. I know I went really quickly on that one. Just trying to keep this video as short as possible. Always feel free to pause, rewind, okay? These videos are here for a reason. You can look back on them whenever you need to. If you ever need to stop at a point and listen to every step, that's fine. All right, so the main reason I showed this example is so that you're not so scared when you see these groupings. You might be like, well, what am I supposed to do with these up front? We already have talked about what to do with these. It's just the distributive property. All right, so for homework tonight, get started on the 2.4 worksheet. You don't have to submit anything tonight. You might as well just get started on it. Do what you can on it. Tomorrow I will do more with 2.4. All right, so get done what you can so that tomorrow's pretty simple. All right, I will see you all back here tomorrow. Hopefully I can get this video to end. All right, there we go.